Okay, coin A is flipped 3 times, coin B flipped 4. So we want to find the probability that the number of heads from the 2 coins is the same. So you can either you have 4 cases. You can either both flip 0 heads, 1 head, 2 heads, or 3 heads. So we're going to use casework to solve this problem. If you flip 0 heads for both coins, then the probability of doing this is just 1/2 cubed, since A is flipped 3 times, and the probability of flipping a head is 1/2, times 1/2 to the 4th, since B is flipped 4 times. This is equal to 1 over 128. And yeah, if you both flip 1 head for both coins, then the probability of doing that is 1/2 cubed. So this is just the probability of getting a head. But then you have to decide which flip. So for A, you flip a coin 3 times, and you want to know which one of these is A. So you'll do 3, choose 1. And you do the same thing for coin B. You have 1/2 to the 4th, and you have to choose which time you flip a head. So if you flip the coin 4 times, you just have to choose 1 time that it will be heads. So this is just equal to 12 over 128. If you both flip 2 times, 2 heads, for 2 heads, it's also 1/2 cubed. And then to get 2 heads, you do 3 over 3, choose 2. That's how many combinations you can have for 2 heads. So you do the same with B. 1/2 to the power of 4, and then 4, choose 2. So that's 18 over 128. And then finally 3 heads. 3 heads for A, it's 1/2 times to the power of 3 times 3, choose 3, times 1/2 to the power of 4, 4, choose 3, and that's just equal to 4 over 128. And now you just add these all up to get an answer of 35 over 128. Question 2, Chandra is paying stuff. So let's just let X be the fixed monthly fee, and then let's let Y be the amount that Chandra paid for the minutes of the first month. Okay, so basically we really don't need to know what this hourly charge is, so you can just ignore that. So basically, Chandra, for her December bill, that's just X plus Y. X is your fixed monthly fee, and Y is just the hourly charge, basically. And that's equal to 12.48. And then it says that in January, her bill is $17.54, since she used twice as much connect time. So that just means that her thing will just be 2Y. So we can solve this equation by doing subtract this equation with this one, and you'll get 2y, no, not 2y, just y. Y is equal to 5.06, and then you can solve for x. That's your fixed monthly fee, and that is also your answer. All right, question 3. Okay, so basically, first of all, you have to find the side length of the cube. So since the area of a cube is just x cubed, if x is your side, then that means that you can find the side length of the cube by taking the cube root of the volume, which is given to you. That's ugly. So you just do this whole thing cubed, to the cube root. And that's just equal to 7 x y squared. So if you want the area of the base of a cube, that's just saying the area of one of the faces. So you just take this and you square it, since that is the area of a square. And you will get an answer of 49 x squared 4 to the power of 4. Y to the power of 4. Question 4. Assuming, this may have been a bit harder, but oops. Okay, so let's just assume that we don't stop picking until all the chips are drawn, I guess. So first of all, if you want the last chip drawn to be white, then basically all the white stuff will be drawn in the first four thingies. So that just means that your last remaining chip has to be red, and you don't necessarily have to draw it or not, but yeah. So basically your last chip has to be red, and the probability of the last chip being red is just 3/5, since you have 3 red chips. See, if your last chip is red, then that guarantees that there are 2 white thingies anywhere in the first 4 draws. So even if you draw a white, then you still satisfy the condition that the last chip drawn is white, since you stop after drawing all white chips or red. So yeah, the answer is 3/5. Question 5. This question looks hard, I guess, but if you just draw some lines, then it'll be easy. So basically what I would do is I would draw some lines to make all of these equilateral triangles you can see here. And after you do that, you'll notice that all of these, the shaded region is basically just this thing. So if you can figure out what one of these thingies is, then you can figure out what the shaded region is. So we're just going to use this to solve this problem. Okay. So if we want this shaded region in here, let's just call it green. This green region, we're gonna find that. So to find this green region, you have to first find the area of the entire rhombus, and then subtract it by the area of the white thing, the white region, which is just part of a circle. So for the rhombus, it's actually just basically just two equilateral triangles put together. So to find the area of an equilateral triangle, if you recall, it's just the root of 3 divided by 4 times s squared. S is the side length. So since you have two equilateral triangles, you do 2 times root 3 divided by 4 times 1 squared. Okay, so this little circle area is just, first of all, the angle of a equilateral triangle is just 60 degrees. So 60 divided by 360 is 1/6. So that means that this arc area is 1/6 of a circle. So that means we can do 1/6 times pi times 1 squared, and that is equal to, it's like, looks like this. Okay, that's equal to root 3 divided by 2 minus pi divided by 6, and that is your green area. So for the entire shaded region, you have 6 of these green areas. So you have to multiply the green area by 6. So let's just do that real quick. 6 times, okay. And you'll get your answer of 3 root 3 minus pi. If you want to solve it all out, I guess you can do that, but if you're lazy, then don't. And that's your answer.